Hello and welcome to API's DevSecOps and Zero Trust. I'm from F5 Labs. We're a research group within F5 of former security engineers who do nothing but research and speak about security topics. We draw data from all over F5, as you can see, as well as external partners to F5 and friends in the industry. Some of those data sources will be presented in today's research briefing. My name is Raymond Pompon. I am the director of F5 Labs, and I've been with F5 for almost 4 years. I've been in security for over 20 years and over 30 years in the IT industry. I have many contacts in the federal security industry, as well as in law enforcement and in government circles. I've also written a book on how to build a security program from the ground up and get it through audit. Let me know if you'd like a review copy. So I'm here to talk about applications. Applications are the heart of how we do business now. One of the things we did at F5 Labs a few years ago was an international survey of IT professionals to measure how important applications are to them. These are the results of some of that survey, as well as a slice of information specific to the public sector or government sector, which you are in. So as you can see, the applications in use is slightly lower than average in the public sector, but still a very key critical component of how we do business. One of the ways we've always traditionally done business is what we call monolith applications. These are the large-scale code bases where things are running on a single computer or a single series of mainframes and computers. And they tend to be very difficult to upgrade and change, and often you spend a lot of time training new programmers on how to use them. One of the things that's come to light in recent years is the digital transformation, which is the changing over of our businesses to actually use more technology and actually transform business process into technical process. And we find that monolithic applications have a hard time with this, especially now in the pandemic, where we're pushing more and more services to remote workers and remote customers. So this has put a lot of pressure on the way we've done things traditionally, and it's accelerated the rise of alternative methods of delivering applications. This is from the F5 State of Application Security Survey, which actually shows that now we're seeing a diverse range of application deployment methods, as 11% is fallen for the mainframe or monolith methods. Now we have the client server, we have multi-tier, and the rise of microservices. In fact, microservices represent an exciting new way to deploy applications. They offer interesting new paradigms and new ways of thinking. I'm not going to go into all these new ways. You can review this on your own, but I just want to throw out the idea that there are different new methods of deploying applications to providing them to end users and to building new layers of trust and security and availability. And you can see there are many large organizations that are taking advantage of these, from very large startups to large organizations like the United States Air Force, which we'll get into a little bit more. This new method is not perfect. When you start slicing an application up into multiple services, you have a lot more interactions, you have a lot more complexity, it's much more difficult to see what's happening. In fact, engineers have to think differently because you don't have the simple cause effect of like running a singular program and getting an output, but now many different programs all having to be orchestrated together. And sometimes once these programs start working together, they can be slow, there can be bottlenecks, and there can be exposures. But let's look into some of those problems. One of the big key things is once you slice an application into microservices, they can run anywhere, private cloud, public cloud, within your data centers, within a colo. As a service, you can integrate more external services into an application that you've never had before. But how do all these applications connect to each other? With APIs. So often you have different connections and whole seams of program flow moving throughout an application that may exist in multiple places, which makes visibility very difficult. The problem, of course, is now that you have your applications running everywhere else, we also now have new interfaces that are exposed to attackers who now can attack these new endpoints, these new flows in ways that we've never seen before. No longer is all your application residing behind your firewall in your data center and may be spread in the cloud at some other location. And all these places represent a widening of the attack surface. This is a serious problem. At F5 Lab, we've been tracking API breaches for some time now. And as you can see, there's some very large organizations that have been hit with breaches over the years. The US Postal Service, Salesforce, T-Mobile, Instagram, Facebook, Apple. These are organizations who you think will understand this technology, will be able to take advantage of things. But in fact, these APIs, as they spread out, represent a lot new attack surface and new methods that people have never thought of. And there are new exposures that are coming to light that are causing significant problems in the industry. Overall, looking at the API incidents, and this is just a pull from publicly known API incidents over the past few years, you can see that they're increasing year by year, almost doubling or tripling. We haven't got the numbers yet for this year, but we are expecting them to be significantly higher than last year as they were the year before. But when we look at these actual security incidents together and we start to categorize them by cause, we see an interesting pattern. If you look over towards the side of the graph, over here under authentication, we see that most of the incidents are occurring related to access control. In fact, if you look at the Open Web Application Security Project, the OWASP API top 10, 5 of those 10, half of those top 10 involve access control. And as you can see, with our incidents, they also match up. We're having a serious problem locking down our APIs as they move between our application services. This is difficult. What's going on here? Well, as we said, as we spread out our services around different locations, different centers, we actually run into a problem of visibility. And attackers know this. They can now, instead of just logging in and attacking at the single point of entry where a user would come in, but they can actually look at each single API handoff within the application service itself as an attack point. As you can see here, we've now decomposed a single application into 6 or 7 different pieces. Each one of those pieces with an API, each one of those can be vulnerable to attack if they are exposed to the internet or to an attacker. This is a serious problem, but it's also not an uncommon problem as we're starting to make larger and larger swaths of application services all meshed together. So how do we manage these security? How do we deal with these problems? As you can see, we have many different services here, and they're all spread out. Well, I'd like to introduce you to somebody who has some interesting solutions to this problem. Nicholas Chillane. He's the head of the software team over at the US Air Force, Chief Software Officer. He's also the lead of the DevSecOps initiative. He's also a very well-known entrepreneur in this space who actually came to the US government to work on security. He's done many famous talks about running high technology like Kubernetes in an F-16 and deploying wide areas of DevSecOps within a military organization, which is known to be very slow to adopt new technology. I invite you to look at his biography and look at his accomplishments. So we've actually spent some time with him, F5 Labs and our team, talking to him about what he's done and some of the things that he's discovered to make this work in his organization. And they're quite fascinating, and I believe they will apply to your organization. One of the things that he looks at is a skepticism towards technology, but in fact, looking at zero trust is something very valuable. In other words, to say, there aren't a lot of good solutions out there, but zero trust is very close to a perfect solution to dealing with security. And so he takes a zero trust approach to microservices and application services and uses DevSecOps to manage all of that. And we're going to go into what that means and how you might want to take advantage of that. The big story is really to look at zero trust as not only how you manage your users, but how you manage your services. As you can see here, here's how a service can be broken out into all these different streams. Just think of these as different users logging into different things and apply a zero trust to that. So let's take a look at what zero trust means when we talk about users. Below is actually a link to an F5 article about zero trust, so you can actually get some more information. This is written by somebody who is an evangelist for Duo Security, so they are big experts in this area. But here we kind of lay out the key pieces of zero trust. For one, the basic concept is all user access is denied by default. We don't trust anyone, whether they're inside our network or not. They basically cannot be trusted until we inspect them and we inspect where they're coming from. And this inspection is not just a one-time thing, but it's a continuous process as the user moves through their application flow. Here are some of those same concepts now broken out into different categories just to make it easier. So the parts of zero trust for users: verify and authenticate. So we're dealing with this. We have a group of trusted users. We have a group of devices that we trust, and then we do an endpoint scan. And this tells us, can we trust this user? We interrogate and check this every time. We have privilege management, which is an access control engine and access proxy, which is managing those authentications and managing that access. And then lastly, we do reviewing and tracking. So we're constantly keeping an eye on the user and what they're doing and where they're going. Now, if we flip this over for services, we can find we can do the exact same thing with different technology and different pieces, but the concepts are the same. Using OpenID Connect and DevSecOps, we can protect the pipeline and attack or look for attackers into that pipeline that are not authenticated. We can manage privilege with OAuth and defined API methods, and we can segregate our environments to keep them from spilling into each other. And of course, we can track the user and the service as they move through our system with JOT tokens and API gateways. Now, I realize that these may be not perfect matches to what we're doing here, but the concept is really the same, is that we are just treating services just like we did users in zero trust. Now back to Nicholas again. When he looks at his DevSecOps program and how it manages all of his service, he really sees it as two pedals, just like in a car, the gas and the brakes. One of them is the constant monitoring piece, and the other one is the pipeline itself. Remember, the pipeline in DevSecOps is the movement from the code itself, where people are actually writing the code as it moves through testing and integration to finally at the end of production. That entire pipeline should be managed with zero trust to make sure that nothing goes into that pipeline that is insecure and could represent a problem. So that actual pipeline authentication, again, zero trust enforcement on the services and containers. We're, of course, encrypting the connections between those containers as they move, so to ensure that we don't have any spilling of data or important secrets. And of course, we're doing change checks. We're looking at how something is, and then after it's changed, doing testing, doing analysis, making sure things aren't broken and new security problems haven't opened up. And of course, the service mesh overall is looking at access controls in the environment to limit lateral movement, meaning that we can't have something that's going to cause a compromise here and be able to move around and cause problems. The other piece, monitoring the actual runtime. As Nicholas says, we want to know about a vulnerability before it's even deployed. Even if a developer makes mistakes, as I said, he can be skeptical about technology, as we should be. But if a developer makes mistakes, which they will, we have gates in place to detect it. So this is really a constant review of all the changes to services with a concept called drift checking. So you have in your configuration, you know how things are supposed to look. You have this image that say, this server is going to be set up this way, running this code and these things. And then I do an analysis in real time to be constantly checking, does this match the way we think it's configured? Is there a deviation? If there is a deviation, we're not even going to try to fix it. We're just going to throw it away and rebuild it from what is known good. So you actually have a situation that if a system actually becomes compromised, it immediately gets detected and deleted, or detected and moved off to a sandbox or frozen so it can be analyzed later, and then replaced with what we know to be a good configuration. So even if there is a breach or there is a new vulnerability, it's completely locked in place and moved aside and replaced with something known good, or rolled back to something that's earlier. And we are constantly reviewing the privileges of those services as they're moving through the system. As we see, a lot of the API breaches are caused when you have actually a user service escalating their privileges, using more than they're supposed to, violating the least privilege concept. So we're also constantly checking, okay, this service is supposed to have this level of access. Has it changed? Naturally, all of these things require a lot of automation for testing and measuring and rebuilding. But we still find that this is an important piece of doing this correct. And when we talk about automation, I should also add one last thing. There can be evil automation. And this is our F5 Labs ThingBot to represent evil automation. all of those API endpoints that are sitting out there. One of the powers of using API delivered services and spreading your applications out is you can now deliver application services far beyond your organization. You could build components within your group and share them with other groups that maybe not are normally you wouldn't, but say like, here's just, a service for around inventory tracking, or here's just a service around keeping track of temperature of something. And they could integrate that service into their applications and thus build upon what you've built. But to do that, you've got to expose your APIs to things beyond your control, which is scary, which introduces risk, which makes them vulnerable to automated attacks. All the same automated attacks we see in the real world for logins can happen here to an API. And the big ones are credential stuffing and brute forcing, but also you see the simple things like SQL injection. So you need to protect those APIs from automation attacks. And one of the ways we do that is with an API gateway that's actually looking for automation. It's looking for malicious activity. And the interesting thing is that you actually start collecting data throughout your pipeline of all your API logins and start profiling that and looking at like, okay, where are they coming from? What kind of devices? What are the requested actions? And with that profile, you'll know what is good. And then with malicious detection, you can start to see the deviations go, that is not a human login. That is not a normal login. That is not a normal privilege. And you can block that. And with a continuous learning and machine learning analysis, you have the ability to actually control that and be able to share services beyond your organization to expose things in the cloud and not have to worry about attacks. Well, thank you for your time. I've thrown a lot of different concepts at you here today. I know I only had a short amount of time. And I want to invite you to come to f5labs.com, where a lot more of this information is available, as well as all of our research reports and all of our data. It's all available for download. You don't even have to register or give your name. You just go in and download and look at it. We update articles every week from everywhere from CISO advice to detailed analysis and data of common attacks, as well as educational device explanations as to some of how these technologies work. So please check us out. Thank you. Here is our contact information if you need it. Feel free to send me a question or follow-up information. Thank you for listening.